This is one of my favorite lessons because we are finally going to find the solution to a problem that you've had to say no solution to for years and years and years. I'm titling it Welcome to Imaginary Island. You'll notice that we have many imaginary friends on our island. The Smurfs, I don't know if you guys even know who they are. We have the Tooth Fairy and Santa Claus. This is where I should probably warn you that if you have younger siblings who like to watch your math with you, you probably should get them away. We have unicorns, the Easter Bunny, a fire-breathing dragon, UFOs. And I know one of you is thinking that UFOs are real, so I will concede that if that's what you believe. Not everyone wants me to think those are imaginary. So we have lots of imaginary things here because we are moving to Imaginary Island today. All we've ever known are real numbers. You have sometimes answered for an answer when you can't get it, no real solution or no real number. And if you asked why you do that, we would say it's because we only know real numbers. So it's no number you can possibly think of that would work for that. Well, starting today, we now know some non-real numbers. When we've done, in the past, the square root of -1, you'll see here, that has always been no real roots or no real answer or no real solution. Today, we're going to learn the solution. And it's not some crazy hard thing you can't do. It's a different form of writing it because it's going to be a magic fairy comes in. She is the fairy from Shrek. And the answer is I for imaginary. So when I take the square root of -1, it would be 1I because the square root of 1 is 1, but it's an imaginary solution, so my answer is I. I would encourage you to look up why that is. It's kind of a long explanation for a video, but I have a couple articles if you want to see them in class on where this comes from and kind of why it is I a little bit. And nothing does a great job of explaining it, but at least it's something better than just, okay, I believe you, and the magic fairy comes. So in order for us to practice this, what you want to think of is we've never been able to take the square root of a negative number. We've always said no real solution. Well, what we do is we actually just take the square root of the number, 5, and this would be 5I. That negative is replaced with I to tell us it's an imaginary number. An imaginary number is really hard to conceive right now, so we're going to just start with kind of going through the motions of it, and then we're going to try to understand a little bit more of what it is later. So number 2, you guys try this one. Hopefully you got 4I. So see how these aren't too bad? Number 3, this is our first one that's not a perfect square. So when I break down 50, hopefully we realize that if we do that, we'd have 2 and 25. Our negative always goes with a circled number. So I'd write the square root of -25 times the square root of 2. We are no longer ever allowed to leave a negative under the square root. So from here, the square root of -25 would be 5I, and then it'd be root 2. So 5I root 2 would be my final answer. This one I want you guys to try quick. Hopefully you found that you would use the square root of -9 times the square root of 3, which would be 3I root 3. Now, why would we ever use numbers that are imaginary? That makes no sense to say that we can't ever think of what it looks like or envision it. We can't put it on a number line and count it and tell me that a 5I is the same as our 5, because it's not. So what happens is there's some properties of imaginary numbers that we will use to get us from the imaginary island, right here, back to the real world, right there. So we're going to leave imaginary island, even though we were only there for a very brief stay, and we're going to enter the real world. Here's what is so great about this. The equation -√1 equals I, which we said earlier. What if I squared both sides of that equation? I can do that, right? Because I'm doing it to both sides. So if I square both sides, I would have I squared equals -1. So whenever you have an I squared, you are no longer an imaginary solution. You now are back into the real world. The answer to I squared is -1. Where would you ever use this? To be honest, the only place I've ever heard it's used is with electrical engineers. Electricians, the properties of this are used with electricity and electrical currents. I've never seen them used. I don't know any electrician that actually uses it, but how we've come up with how to do electricity is supposedly from this. For our purposes, it's going to be kind of like doing things with a variable. We're going to kind of be transferring like we would a variable and just learning the properties of it. But if you would go more in depth in math as your career, let's say, hopefully you'll learn more about it. If any of you want to be an electrical engineer and come back and teach me more about this, I would love it because I want to see how you'd actually use it, just because I think that'd be fun. So here we go. I squared is -1. So for some reason my dot disappeared here. I don't know why. My dot raised up. This is supposed to be just timesing. So I have -3i times 2i. When we multiply i's, we do it just like we would with a variable. So -3 times 2 is -6, and then I times I would be I squared. Now after what we just saw, we realize I squared is -1, right? So I can replace that I squared with a -1, and in fact I have to. And when I take -6 times -1, I get an answer of 6. So I started with two imaginary numbers, and I am now a number we can actually see. 6. We know what 6 means. 6 apples. 6 trees. We can count 6. We get 6. The 3i and the 2i, maybe not. So you guys try number 6. You would get 12i squared. Since I squared is -1, we would have -12 as our answer. Multiplying radicals, it's really important in order for me to multiply radicals that have a negative under them, I have to get rid of the negative before I multiply them. So the square root of -12 I'd break down into -root4 times, or excuse me, root -4 times root3. So I'd have 2i root 3 times, and I can't leave this root -2. I have to actually write this as I root 2. When you can't break down a square root, you leave the 2 in there, but you have to pull the negative out and it becomes the I. Almost think of it as flipping over. I'd have the I root 2. So I bring that down. Now when I multiply here, I multiply my outside numbers, which would be a 2 and a 1. So I'd get 2. I times I is I squared. Root 3 times root 2 would be root 6. Since I know I squared is -1, I would have -2 root 6. You guys try number 8, please. Hopefully when you broke down the square root of -8, you got 2i root 2 times I root 3. So you would have 2i squared root 6. Remembering that I squared is -1, we have -2 root 6. Strange that we got the same answer as our last problem, right? Because they were totally different problems, but it did work out to be the same. Last one. -root 27 times -root 9. Go ahead and pause the video and try this one. Hopefully for this one you got 3i root 3 times 3i, because 9 is a perfect square. When I multiply those, I get 9i squared root 3. I squared is -1, so I have -9 root 3. This is just an introduction to imaginary numbers. We will be working with them in future videos and as you keep going to math.